So in previous lecture we have finished with the introductory part of this electrochemistry, and we have already seen what do you mean by this conductance of the electrolysis solution. So conductance is what? Simply the inverse of resistance. That is the quantity 1 upon R is the measure of what? Conducting capacity C of the conductor, which is simply called as a conductance of a solution. So next term is the specific conductance. Okay. So why we need to just simply cannot find out this conductance of a solution? So because this conductance of solution will be depending upon various parameters like concentration, then temperature, and other parameters. Okay, like purity of the sample as such. And this resistance also depending upon what? Resistance depending upon the material type, but material is like solid materials basically for the resistors, and we can directly measure the resistance of that particular resistance by using like multimeter or some other techniques. Okay, so this resistance can be determined for the solid materials, but in order to determine the conductance, we have already seen this conductance is specifically for what? Either the molten solutions or the for the um, our solutions. Okay, molten salts or the solutions. So there we cannot like have the direct measurement for the resistance. So that's the reason why we have to like study the conductance, and we are not only stopping at the conductance measures because we cannot measure the conductance directly. So there are the other things like specific conductance is there, molar conductance is there, so that we can determine by using the conductometer. Okay, that conductometer will tell you the specific conductance or the molar conductance. Okay, so there are the quite important thing in order to determine that. So one important thing is the cell constant. Okay, cell constant. So consider the derivation for that. So consider specific conductor. Now the resistance R for the metallic or the electrolytic conductor is directly proportional to what? Its length and inversely proportional to its area of cross section. That is, resistance is directly proportional to length and inversely proportional to its area of cross section. This is the simple formula for the resistance of a conductor, or we can say that this resistance is equals to some resistivity rho into L by A. Okay, so where this rho is the constant which is called as a specific resistance or simply the resistivity for the given material. Okay, resistivity or the specific resistance. Now we know that this resistance and conductance have the inverse relation. So again we will try to rearrange this equation in terms of some inverse equation, that is rho is equals to R into A upon L. Simply simplify the equation for the rho. Therefore the specific resistance of a conducting material, which can be the resistance in the ohm for the one unit length of material and one area of cross section unit. Okay, so we can say that this rho is become equals to R when A is equals to L is equals to 1. Okay, unity. Okay, so here unit will be in the square meter or square centimeter, and for length it is either centimeter or meter. Now we know that this conductance of a conducting material, which is inverse of or reciprocal of its resistance, that is L is equals to 1 upon R. So we can simply take the inverse of first equation, that is this equation here. So therefore we can see this L is equals to 1 upon rho A by L, or this 1 upon rho is called as a kappa. Okay, kappa, which is nothing but what? It is the specific conductance. This kappa is equals to what? L by A into this L, or sometime it is also be represented by the symbol of G. Okay, so in various reference book you will find either the symbol L or the symbol G, which is specifically for the conductance of a solution. Okay, it is the conductance simply. So this kappa is simply what? The inverse of specific resistivity or the specific resistance. So it is also called as what? Specific conductance of the solution, or the conductivity of the solution. Conductivity of the solution, and it is what? It is defined as the conductance of a cubic material of age and unity. Okay, so it may be either expressed as centimeter, per ohm per centimeter, or uh, its SI unit can be like per ohm per meter. Okay, because here you can see this. What is the unit of this conductance? It is per ohm because it is the inverse of resistance. And what is the unit of length? It is either see, consider for SI it is meter, and for area it is meter square. So 1 meter get cancelled, so we have been left with meter inverse. So this is the thing, okay, for the unit. And also for the other unit, that is reciprocal of this ohm, is also known as Siemens. So SI unit for this kappa can also be expressed as the Siemens per meter. So you might have been like given the unit in terms of various terms, like, so specific conductance can be measured in case of with the current flows through the unit cube of the solution, but it is not a convenient quantity for the discussing of the conduction process of the solution of the electrolyte, since the given volume of different solution containing different amount of electrolytes, it is obvious that the solution of different concentration which is having different specific conductance. So we can say that this conductance is depending upon what the concentration. Hence, in order to compare the current carrying ability of the given electrolyte, the change in the concentration is also needs to be considered. So that is considered in terms of molar conductance. Okay, so next term is the molar conductance of a electrolyte. So what do you mean by that molar conductance? So let us see that. Now, the molar conductance of electrolyte is simply related with the concentration term. Okay, concentration term. So it can be defined as the conductance of a volume of a solution containing 1 mole of dissolved substances. Okay. So if we contain the 1 mole of substance in the given volume, and it is placed between the parallel electrodes which are separated at the unit distance, and it containing the large amount to be flowed in between this electrolyte. Okay. So consider the conductivity cell in which the electrodes are placed at 1 meter apart, and the sufficient area has been given so as to solution can be placed in the given container. Okay, and the concentration of solution is 1 mole. Now the conductivity of such a cell can be simply the molar conductance of a solution. So since the concentration C of the solution is expressed in terms of moles per liter, so its volume is what? Inverse of concentration, that is 1 by C liters per mole, or volume in the cubic meter, that is 10 raised to minus 3 meter cube. Okay, cell with the volume and electrolyte which is separated by 1 meter would be equivalent to what? 10 raised to minus 3 uh, per liter upon C. So unit cell which is placed alongside each other. So the conductance of such a cell, which is definition of the what? The molar conductance lambda m, which is given by what? 10 raised to minus 3 meter cube per liter divided by concentration into specific conductance. So sometime it might be given in terms of your what? The 10 raised to minus 3 is for the meter cube, but if suppose concentration or the solution is given in terms of centimeter cube, then we need to just multiply by using 10 raised to 6. So overall we can get thousands of k. This is more familiar formula, thousands of k upon C, where k is what? The specific conductance, C is the concentration in moles. Okay, moles. So this equation is the relationship between molar conductance and the specific conductance. So in practice, one can use any convenient methods so as to calculate the resistance and calculate the conductance of solution, and hence the specific conductance using this equation, and finally the molar conductance can be calculated. Now what about the units of this molar conductance? So molar conductance is there, so that's why we have to like mole in the units. So the specific conductance has the unit of Siemens per meter, and the concentration of electrolyte can be often expressed as mole per dm cube or mole per liter. So it is convenient meter we can inverse, so meter cube. So the unit of molar conductance will be what? Siemens per mole meter square. Okay, or Siemens meter square per mole. Now in next lecture we will try to see the variation of molar conductance with the concentration for weak and strong electrolyte.